I'm going to start by showing you a couple of examples that illustrate the need for comparers. Suppose I have an array of strings and I want to sort them. Here's the array, and normally the way you would sort an array is by calling a method array.sort. It's a static method, so you pass the array to be sorted as an argument. What happens if I run this code? Let's try it. Well, that's worked beautifully. We have all the strings sorted in alphabetical order, and that's pretty impressive if you think about it, considering there's nothing in the code I've written that says how to sort the strings. Remember, arrays are designed to store anything. The array type and the array.sort method know nothing about strings, yet somehow this array was still able to sort the strings without any trouble. The reason that this works is because strings implement iComparable of string, thereby telling the world that any string knows how to figure out whether it comes before or after any other string. The array is able to indirectly leverage that to sort the entire collection of strings. Now I'll replace the definition of the array. In place of the array of strings, we have an array of food instances. The same food class that we were using earlier in the course. Everything else is the same, I've just changed which type is stored in the array. For the benefit of anyone who's jumped into the course at this module, I'll quickly remind you what the food type is. Let's go to that file. It's basically a class that encapsulates two fields, a string containing the name of a food and an enum that gives its food type. And earlier in the course, I implemented equality on this class, but that's not going to affect anything in this module, so I've hidden all that code in a C# region. I've also made a minor change to the class. I've had the toString method write out both the name and the food group. In previous modules I kept it simple by just writing out the name, but for this module having it write out both is going to be a bit clearer. Anyway, let's go back to the main method and run this code to see what happens when we try to sort the foods in the same way that we sorted the strings. Well, that's not very good, is it? Massive exception. If we look at the exception message, we can find buried in it something saying that at least one object must implement iComparable. And of course what that is telling us is that you can't sort the food instances unless you have some means of comparing them, determining which of any two food instances comes first. And remember, for the food type, we deliberately avoided implementing iComparable of t because there was no obvious, natural way of ordering food instances. And actually, think about what I said when I set up this program. I said we wanted to sort the food instances. Well, sort them how precisely? Sort them by their names? By the food groups? I never said. So really, I just wrote some code to solve something that's completely unsolvable unless I supply more information, so getting the exception was hardly surprising. In fact, I never said how I wanted to sort the strings either, but that worked because there's an implicit understanding that sorting strings probably means alphabetically unless you say otherwise. And that's reflected in string's iComparable of string implementation, which does sort alphabetically. Well, let's suppose I want to sort these food instances alphabetically by their names. How can I do that? That's where a comparer comes in.